Bright QT. Every student matters.
Now let us look at some of the questions in this exercise which are based on the same concept here. A plastic box with these dimensions is to be made. It is open at the top. So, we do not have the top surface. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. Now, we have got only 5 faces, right, out of which face is missing? The top face is missing. What was the area of top face? L into B. So, the area required in this question is, this is the area of the floor or the bottom face plus the lateral surface area, that is twice of BH plus HL. This area is required in this question. Okay. So, let us put the dimensions that are given: length 1.5, breadth 1.25, okay, plus twice of BH 1.25 into, now this is in centimeters. So, let us convert it into meters. So, I will write it 0.65, okay, plus 0.65 into 1.5. So, this is the area of sheet required to make this box. And how much will it be? You may calculate this area by writing 1.5 as 3 by 2, 1.25 as 5 by 4, right. So, that will make the calculations a little simpler. Now, this can be written as twice of, this is 5 by 4, this is 130 by 2, right. So, 13 by 2 if this decimal was here. So, now I can write it as 1.3 by 2 plus, this is again, if I write is 1.3 by 2 and this is 3 by 2, okay. So, this will give me 15 by 8 plus twice of, so I will remove this 2 and these 2's from here. So, this will give me 6.5 by 4 plus this will give me 3.9 by 2. Now, we can take the LCM as 8, right, 15 plus this can be written as 13, and if you multiply this by 4, this is 7.8, so 15.6, and this is, these two will make it 30.6, and if you add 13, 43.6 here by 8. Now, we can calculate it. 8 5s are 40 and then a decimal 0.45. So, 5.45 meter square of the sheet is required to make this plastic box. Okay. Now, cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20. Now, 1 meter square costs rupees 20. So, 5.45 meter square will cost 5.45 into 20. Okay. Now, you need to multiply this. This is 5.45. So, it will be 10.90 if I just multiply it with 2, right, and there is a 0 2. So, it will make it 109 rupees, right. So, this is what it will cost to make this box. Okay. All these questions are based on same pattern. We are given the dimensions of a cuboid or cube and we need to calculate the surface areas. So, length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of the room and ceiling. Now, this time the bottom face, because you do not have to paint your floor, right. So, we need these 4 faces which are the lateral faces of this room and the ceiling. So, which dimension or which face is missing? The bottom face, or we can say floor is missing in this question. So, L into B we do not require. What I am trying to say is the total surface area is 2 into LB plus BH plus HL, right. Now, in this question we do not require one length into breadth. So, the area that we require is LB plus twice of BH plus HL. So, this area needs to be painted. Now, look at this. The length, breadth and height are given. So, let us find this total surface area that needs whitewashing is length into breadth, that is 5 into 4 plus twice of breadth into height, that is 4 into 3 plus height into length, that is 3 into 5, 20 plus this is 12, this is 15, 12 plus 15 is 27, 27 into 2 is 54. So, the area that needs to be painted is 74 meter square. So, this is the area that needs to be painted. Now, cost of whitewashing the walls of this room and ceiling at the rate of 7.5 per meter square. So, to 1 meter square of whitewashing costs us rupees 7.50. So, 74 meter square of whitewash will cost us 74 into 7.5, right. Now, again you can write this 7.5 as 15 by 2 for the calculation. Now, this you can cancel it and write 37 here. Now, you know how to calculate, right. This is 555. So, this much it will cost. Okay. The floor of a rectangular hall has perimeter 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. Now, if the floor is rectangular, that means we are talking about a cuboidal hall, right. Now, this rectangular hall has got the perimeter, the rectangular floor has got the perimeter of 250 meter. Now, look at the cuboid once again. Okay. In this question, we need to find the cost of painting the 4 walls, that is these walls, right, and the front and the back one. Okay. So, what will be the area of this wall? This dimension into this one. If I consider it B and this H, so this is the area B into H. Similarly, this area is also B into H, so it is twice of B into H, and the back face, front face has got the dimensions L and H. So, the area will be length into height. Similarly, the back face will have the same area, so it is twice of L into H. So, this is the area that we need to paint. Now, look at this carefully. If I take H as common and 2 as common, what will be inside? B plus L. Now, what is this? This is the perimeter of the floor. Floor is rectangular in shape, has got the dimensions B and L. So, what will be the perimeter? It is twice of V plus L. So, if you multiply it with H, you will get the lateral surface area. Now, the perimeter is given, okay, and what else is given? That at the rate of 10 per meter square, it costs us 15,000 rupees to cover the 4 walls or the paint the 4 walls. So, area of the 4 walls is equal to total cost 15,000 divided by cost per meter square, that is rupees 10. So, this is the area of the 4 walls. Now, what we need to calculate in this, height of the hall. So, perimeter is already given, we need to find the height. So, 1500 is equal to height into perimeter, right, this we proved here, and perimeter is 250 meter. So, the height is 1500 divided by 250, okay. You can cancel it, 25 6 are 150. So, this is 6 meter. Height of this rectangular hall is 6 meters, right. So, now the next question, the paint in a certain container is sufficient to paint an area equal to 9.375 meter square. How many bricks of dimensions these can be painted out of this container? So, let us calculate the area that needs to be painted, that is area, surface area of one brick, right. Now, this much area can be painted out of the available container, okay. Now, if I divide this area by area of one brick, it will give me the number of bricks that can be painted using this paint. I hope this is clear to you, okay. So, surface area of one brick. Now, brick is cuboidal in shape, so it is twice of length into breadth, breadth into height plus height into length, right. So, putting these values for length, breadth and height, we will have twice of length into breadth plus breadth into height plus height into length, right. So, how much area is this? This is 225, this is 75, this 7.5 into 225 can be calculated by writing it separately like this, 7.5 into 2.5, right. Now, if I write it as 15 by 2, then I can multiply it with 22.5, right. Now, this multiplication is easier now, 15 5s are 75, 37, so 333. So, it will be 337.5 by 2, which can be further written as 168.75, right. So, it is 168.75 that we need to add here. 225 plus 75 is 300, 300 plus 168.75 is 468.75. Now, you multiply it with 2, so it will give you 937.50 and the unit is centimeter square. So, this is the area of one brick. Now, this much area we can paint, right. So, how many bricks are required? The total area that can be painted divided by the surface area of one brick, and we cannot divide meter square in by centimeter square, right. So, we will have to convert meter square into centimeter square or centimeter square into meter square first. So, to convert meter square into centimeter square, I will multiply it with 100 into 100, right. So, number of bricks will be equal to total area that can be painted by area or surface area of one brick. Hence, total area is 9.375, but it is in meter square. So, what I am going to do is I will multiply it with 100 into 100. So that will make it in centimeter square, and I will divide it by 937.50. Okay. Now look at this. If you multiply this by 100, it will give you 937.5. So this can be cancelled with this. So I require 100 bricks. That is, using the paint in the container, we can paint 100 bricks of these dimensions, right? So looking at the next question, we have got a cubical box this time, each edge 10 centimeter, and another cuboidal box which has got dimensions these. Okay. When box has a greater lateral surface area, and by how much? So which should be the right word here. Which box has the greater lateral surface area and by how much? So we need to calculate lateral surface area of both these boxes. One is cubical, one is cuboidal. So to calculate the lateral, so the first part I am doing here, lateral surface area of cubical box. How many surfaces are there? 4 lateral surfaces, so 4a square, where a is the dimension or edge. So 4 into 10 square, that is 400 centimeter square, is the lateral surface area of the cubical box. Now let us look at the cuboidal box. So the lateral surface area, right? Lateral surface area of cuboidal box. So if you have learned the formula twice of LB plus BH plus HL, then you know that you do not require L into B in this case, because we are just talking about the lateral surface area. So we are not concerned with top and bottom. So it will be twice of, we will leave LB. So BH plus HL, right? And the dimensions twice of 10 into 8 plus 8 into 12.5, right. So this is the lateral surface area of the cuboidal box, which is 80 plus, this is 125. If it was 125, the double would have been 250, 4 times 500, right, 8 times 1000. So now it is 12.5. So 12.5 into 8 will give you 100. Okay. So 100 plus 80 is 180. 180 into 2 will give you 360. So this is in 360 centimeter square is the lateral surface area of the cuboidal box. Now I think we need to compare these. Which box has a greater lateral surface area? So as we can clearly see, the cubical box has got greater, right, you write it in your language, that the cubical box has got greater lateral surface area. And what is the difference? 400 minus 360, that is 40 centimeter square. So cubical box has got greater lateral surface area, and how much is it greater by? So by 40 centimeter square, right. Now we need to comment on the total surface area. So what was missing? The top and bottom surfaces. So to calculate total, we can add twice of those surfaces. So what I mean to say is, total surface area of cubical box will be 6a square, right, which is 6 into 10 square, that is 600 centimeter square, right. Now look at this cuboidal box. This much we have already calculated, 360. So total surface area of cuboidal box will be the lateral surface area that we have already calculated plus the area of top and bottom surfaces, that is twice of length into breadth. So twice of length into breadth. What was the length? 12.5 and breadth 10. So 12.5 into 10. So this will give us the total surface area of the cuboidal box. 360 plus this is 125 into 2, that is 250. And how much is this? This is 610 centimeter square. Now look at this. The total surface area of the cuboidal box is greater. So the total surface area of cuboidal box is greater. And what is the difference? 610 minus 600, 10 centimeter square. So by 10 centimeter square, the total surface area of cuboidal box is greater than the total surface area of the cubical box. Right? So write this in your language. This will be your answer. A small indoor greenhouse, which is also known as herbarium, is made entirely of glass panes, including the base, okay, held together with a tap. So it is held together with a tape. It is 30 centimeter long, 25 centimeter wide and 25 centimeter high. What is the area of the glass used? How much of tape is needed for all the 12 edges? So the edges, on the edges we will have a tape to hold it together, okay, and there is glass pane everywhere on all the surfaces. So we are looking for the total surface area of this greenhouse with these dimensions. So first part, total surface area of the greenhouse is twice of length into breadth plus breadth into height plus height into length. So it will be, this is 750, this is 625 and this is 750 once again. These two will make it 1500 and this will make it 2125. If you multiply it with 2, it will become 4250 and it is in centimeter square. So this much surface area is, right, this is the total surface area of this glass herbarium and this is the total surface area of the glass used. So second, how much of tape is needed for all the 12 edges, right? So what are the 12 edges? If you look at the cuboidal box, now look at these edges. These 4 edges are heights, right? So we would require 4 into height. We are talking about the length of the tape used. So these are 4 heights, okay. Now look at this. This edge, this edge, this edge and this edge are the breadths. So we are looking for 4 times the breadth, and this edge, this edge, this edge and this edge are lengths. So 4 into length. So this much tape will be required, that is 4 into length plus breadth plus height. Tape required to cover 12 edges is equal to, and this formula makes sense also because we have got this is a symmetrical figure and it has got total of 12 edges. So 4 each type of edge, 4 each type of dimensions, 4 lengths, 4 breadths and 4 heights. So 4 times L plus B plus H will be the length that is required. So what is L? 30, 25 and 25. So 4 into 30 plus 25 plus 25, this much length is required. So this is 50 plus 30, 80 and into 4 it will make it 320 and the unit here is centimeter. So this much tape is required to cover all these edges so that the herbarium is held together with the tape. Now there is Shanti Sweets stall and it was placing order of making cardboard boxes for packing their sweets, right? Now, two sizes of boxes were required. The bigger one of dimensions these, smaller one has got the dimensions these. For all the overlaps, 5% of the total surface area is required extra. So, these dimensions are for length, breadth and height, right? While making the box, there are overlaps, right, about the edges, or there may be overlaps to cover that box, right. So, we are not concerned about the design or structure of the box apart from the fact that these three dimensions, length, breadth and height, will give us the total surface area, and we need to consider that 5% of the total surface area is required extra. So, whatever surface area we calculate, we will add 5% of that in that area. Okay. Now, I will tell you while we proceed with the question. Now, cost of the cardboard is rupees 4 for 1000 centimeter square. Find the cost of cardboard required for supplying 250 such boxes. Now, 250 boxes of each kind, right, the smaller box and the bigger box. So, let us focus on the bigger box. Total surface area is twice of LB BH plus HL, right. So, it will be equal to twice of, this is 500, this is 100 and this is 125. So, this is 725 into 2, so 1450, and the area is in centimeter square. So, this is the total surface area of the bigger box. Now, what I am trying to say, what are the overlaps? It will take 5% of the extra box, right. So, 5% of this has to be added. What I mean to say is the surface area of the cardboard required will be this much we require, yes. For the overlaps, we would also require 5% of the same, right. So, this will be, now you can calculate it easily by cancelling this. This is 2, so this will give you 72.5. So, 72.5 meter square or 72.5 centimeter square is required extra. So, we will add it here. So, that will make it 0.5 to 1522.5 centimeter square for the bigger box. Similarly, we will calculate for the smaller box. Smaller box has got the dimensions these. So, for smaller box, the total surface area is equal to, these are the dimensions, so twice of 15, 12, 5. So, 15 into 12 plus 12 into 5 plus 5 into 15. Okay. How much is this? Twice of, this is 180, 60, 75. 180 plus 60 is 240. 240 plus 60 would have been 300. So, this is 315. 315 into 2 is 630. So, this is in centimeter square. 5% for the overlaps. So, the cardboard required will be 630 plus 5% of 630 for the overlaps. Again, you can cancel it, this by 2, and this will give you 31.5. So, if you add it, it will be 661.5 centimeter square. So, this much is the surface area of the cardboard required. Now, let us look at the next part of the question. Now, cost of cardboard is rupees 4 for 1000 centimeter square, and we need 250 boxes of each kind. So, this is the surface area of one box, cardboard required for one box. So for 250 such boxes, we will require this much into 250, right? And cost is rupees 4 for 1000 centimeter square. So let us look at this. So for 250 boxes, the area will be 250 into 1522.5, right? The area will be this much. Now rupees 4 for 1000 centimeter square. So for 1000 centimeter square, it will cost us rupees 4. So for 1 centimeter square, it will cost us 4 by 1000. Now look at this. For this much centimeter square, it will cost us 4 by 1000 into this. So let me multiply it by 4 by 1000. I hope this working is clear to you. This is just the simple unitary method. Now look at this. This is 4 by 1000, so it is 250. Now this 250 will get cancelled, and this is the amount in rupees to make 250 boxes, bigger boxes, right? 1522.5 rupees. Okay. Similarly, for the smaller one, the cardboard required is 661.5 centimeter square. For 250 such boxes, the surface area of cardboard required I hope the method is clear to you. So you can write all these statements yourself, right? So this will be 250 into 661.5 centimeter square. Now cost, we already know that rupees, how much is the cost? Rupees 4 for per 1000 centimeter square, right? So for 1 centimeter square, it will be 4 by 1000. So what we need to do is we need to multiply this with 4 by 1000 to get the total cost. So total cost will be 250 into 661.5 into 4 by 1000, right? So again it will give you 250 here, and 250 can be cancelled. So 661.5 rupees is the cost. Okay. So the total cost will be the sum of cost of smaller boxes and bigger boxes. So the total cost, let me write it here. Total cost will be 661.5 plus 1522.5. So it will be 661.5 plus 1522.5, and the sum will be 4 here, 812. So it will be rupees 2184, right? So this will be the total cost. Now Praveen wanted to make a temporary shelter for her car by making a box like structure with tarpaulin that covers all the four sides and top of the car, with the front face as a flap which can be rolled up. Assume that the stitching margins are very small, okay. So in this question we don't have to worry about the overlaps and all, right, and therefore negligible, so we can neglect it. How much tarpaulin would be required to make the shelter of height and base dimensions as these? So now we do not have to make the bottom surface of this cuboid, right? So this is a temporary shelter which is a cuboidal shape, box like shape, right, with no bottom, because we are going to cover a car, we are going to cover the top and the lateral surfaces. So only the bottom face is missing, right? So the dimensions are height and length into breadth are given. Length 4 meter, breadth 3 meter, and height is 2.5 meter. So the bottom surface is not required, so 1 L into B is not required. The surface area that is required is L into B plus twice of BH plus twice of HL, right? Why I have not taken 1 L into B? Because we do not require the bottom surface. So let us put the values in this formula. length into breadth 4 into 3 plus twice of breadth into height. So, 3 into 2.5, right, this is 2.5 plus twice of 2.5 into length, that is 4. So, this is the surface area of the tarpaulin required, which is 12 plus 2.5 into 2 will make it 5, 5 into 3 is 15. Again this is 5, 5 into 4 is 20. So, this is 32, 32 plus 5 is 37. So, it is 47 meter square tarpaulin required to cover this car. Okay. So, this was about this exercise. I hope now you are comfortable with finding surface areas of cuboidal and cubic shapes, right. There may be some twists in the questions which you need to understand, like some surfaces might be missing. So, you have to take out those surfaces from the formula that you have learnt, right. Thank you.